So hi everyone. Our project is going to make an all-in-one multifunction air purifier. So now, as you can see, now I'm doing for the input part. We will have 4 input, which is the first one will be the power, second one will be the speed of air, third one is humidity, and the fourth one is the air quality sensor. And then we also got 4 input, which is one is the low fan speed, second one is high fan speed, and then the third one is moisture of air, and then the fourth one is the HEPA, which is the high efficiency particulate air filter. So now I will set the AND gate. We are using 4 AND gate in here, and then now I'm going to put a NOT gate here, and then let me connect the output with the AND gate. And then since the first one is the power button, so I will connect all the first input with all the AND gate, and then the NOT gate is connected to the speed of air, which is the second output. And then now I'm going to connect with the input part. Okay. Okay, right now, okay, let me set the name, which is A, B, and C, and then last one will be D. Okay, A represent the power, B represents speed of air, C will represent humidity, and D will represent air quality sensor. And then the output W is low fan speed, X is high fan speed, Y moisture of air, and then Z is the HEPA filter. Okay, so now let us press the triangle, this triangle, which is the run button. Okay, so this is the basic schematic diagram, basic gate. So now let us continue with our NAND gate. So firstly, also same, we put like 4 input here, and then 4 output here. And then let's insert a NAND gate. Same as just now, we are going to have 4 output, but now for NAND gate part, we need to insert for 8 NAND gate. So as you can see now, I'm showing you how to do for the NAND gate in this Quartus. Then let's connect the NAND gate with the output, and then connect the NAND gate with the input. Alright, so this one, the AND gate is connected to the second one and the third one. Okay, and then connect back to the second output. Okay, for the third one. Okay, so for the first one, this will be A, this will be B, C, and D. Okay, this one is W, X, Y, and Z. Okay, so this, okay, let me set the number first. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this is the NAND gate diagram.
Alright, so now I would like to present how we can get a no configuration logic circuit based on our circuit that we design. At the very first step, like usual, we have to create 4 input and then 4 output for our circuit. After that, we have to arrange them in a proper position. Alright, after we arrange the positions, we have to build our circuit. So now, for no configuration circuit, right, we are only can use NOR gate. So now we would like to show you how we can get an AND gate from NOR gate. So as you can see on the screen, there are multiple of NOR gates. So how it works, let me explain to you. First, three combinational NOR gates can actually function same as a 2-input AND gate. So for the first three 2-input AND gates, right, we use the same idea to build it with two NOR gates which connect with the same itself. For example, for the first one, right, the first NOR gate is connect with two same A input A is connected together, and then the second NOR gate also the same. The input B is connected to the NOR gate itself, and then they connect together with one NOR gate again to function like an 2-input AND gate. So how about the fourth one, 3-input AND gate? We're actually using the same concept, but now we have to add one more NOR gate as we have new one more input now. So the rest is the same like previous 2-input AND gate, where the NOR gate connect with the same input itself. Like for the first one, right, NOR gate is connect with the two same input A. So the rest also the same. So finally they have to connect it again with one more NOR gate to become 3-input AND gate. So basically the idea is when we have more input, right, we just add the NOR gate. We have one more input, so we just add one more NOR gate. 2 input, we just add 2, like that. Right, after that we have to connect all the wires together to build a complete circuit. Okay, so next I would like to explain how we can get a NOT gate by using NOR gate. As you can see, right, our Boolean algebra actually we have B bar, so we need a NOT gate to let our system work normally. So in NOR configuration, right, we actually can use one more NOR gate to represent a NOT gate, which is connect with two same input like previous. In our circuit, E is connect with two input B, so it will become B bar. Alright, after that we have to connect all the wires together to build a complete circuit. After that, we also need to fill in all the input names as well as the output name. Next, we have to arrange again the wire connection so that other people can see our circuit clearly. After we rearrange our circuit, we just press the compile button, which is a triangle button on the top. So after that, we just wait for the Quartus to process itself.
We're going to build our timing diagram. So first we have to press the file and then create a new file for it, which is University Program VWF. After that, we just right click and then insert NOT, and then we click this NOT finder, and then we click the list, all the input and output. We just press this, the second button, and then it will appear on here, and then we just press OK. After that, we have to edit our grid. So first one, we just go to edit, and then we press grid size, and then we change to microsecond, and then the period is 1. Next, we just set end time. Then we go to edit and set end time, and then we just change to 16 as we got 16 possibility. And then we go to our first input, which is A, and then we press edit, and then value, override clock. And then for the first one, right, we just put the period as 16. And then the following is divided by 2. So we just put value, override clock, and then we divide by 2, which is back. And then the third one is C. Override clock 4. And then the last one, 4 divided by 2, which is 2. So the same value, override clock, and then we just set it as 2. After that, we can press Ctrl and then we click the input. and then we right click. For the group, we just put input, and so it's better for us to see the input outside. So then we set our font as after this we just press simulation and then run the simulation, and then we just wait for it. Alright, so this how we can get a timing diagram.